this microcontroller. So it is an ARM advanced RISC machine. So as I told, in this microcontroller we have an ARM based processor. So again it is dependent on the again it is on the RISC. Again it is on the RISC architecture. So RISC again stands for reduced instruction set computing. Okay, all the instructions which we execute in the ARM processor are reduced instruction set computing. Okay, so again LPC2148 is a 32-bit microcontroller. Okay, it can handle up to it can handle up to 32-bit data at a single time. So again it is based on ARM version 7. Okay, it based on ARM version 7. LPC2148 microcontroller is based on ARM version 7 family. So it can be called as ARM 7 TDMI. So ARM, then 7 is the version. T stands for thumb instruction, which means that in this microcontroller or in this ARM version 7, even the thumb instruction can also be executed and is available in a 64 pin LQFP package. So 64 pin anteliದ್ರೆ again 64 pin. So LQFP stands for low profile quad flat package. So what is low profile quad package anteliದ್ರೆ? So low profile is nothing but it is a low cost microcontroller or low cost processor. So quad anteliದ್ರೆ, so there are 4 sites in this ARM processor, ARM version 7. So there are 4 sites in this processor. Again flat package, so it usually looks like the structure of the microcontroller usually looks like a flat like structure. Okay, again it has on chip static RAM. So everything, so here in the microcontroller, every component is embedded on the system on chip. So that's why it is called as SoC stands for system on chip. Every components on the microcontroller, including RAM, ROM, and ARM processor, everything is embedded on the single board itself. So that's why it is called as the system on chip. So in this, it has an on-chip static RAM of 32 kilobit and an on-chip flash memory of 512 kilobit. Okay, so it has a RAM. The size of RAM is 32 kilobit, and the size of the flash memory is of 512 kilobit. Okay, so again LPC2148 has an on-chip boot loader software, so that can be used to program the microcontroller using the feature of in-system programming, which means that without using an external computing, so by using a bootloader software which is installed in on the microcontroller, we can execute the programs. On the microcontroller. Okay, it also has the feature of in-application programming. In-application programming, using which the user can program the microcontroller without using the bootloader software. So without using the bootloader software and by using a Windows software or by using a Keel IDE, we can implement the program and we can dump that program. After compiling, we can dump that program to the microcontroller to execute the program. So that's what in application programming means. In system programming and without using any IDEs, so we can execute the programs without using any IDEs. We can execute the programs on the microcontroller. So as I told, everything is embedded on the in microcontroller. Everything is embedded on the system on chip. So everything is embedded on the system, which means that the processor ARM version 7 as well as the RAM, ROM, and other peripheral devices, other peripheral drivers, all these are embedded on a single chip. So again, LPC2148 has two 10-bit ADC. So that is called as ADC0 and ADC1 for successive approximation type. So what is ADC and ADC is nothing but analog to digital converter. So if we are using any if we are executing any programs related to an electronics, like if you want to convert some data, some analog data into the digital data, then we will make use of this ADC. So the size of ADC which is available in the LPC2148 is a 10-bit, and there are two ADC. The first ADC is called as ADC0 and the second ADC is called as ADC1. Okay, ADC0 and ADC1. So there are two analog to digital converter that are available in the LPC2148 microcontroller. Okay, so it also has a 10-bit DAC of register string type. So again, we have one DAC. So that is nothing but if you want to convert any data from digital to analog, so then we will make use of this DAC interface. The size of the DAC is a 10 bit. Okay, so we also have a DAC interface on our microcontroller, on our LPC2148 microcontroller. So LPC2148 ARM version 7 DMIS microcontroller with USB 2.0 full speed device. It supports, it usually, this microcontroller, LPC2148 microcontroller, has an USB port. So the version of that USB port is 2.0, which means that we can connect other peripheral devices through the USB to the microcontroller. So LPC2148 microcontroller, and it has a three-stage pipelining. So here all the instructions executes based on the three-stage pipelining. So obviously we have studied in second module, so the pipeline architecture, right? So in the second module we have studied the pipeline architecture. In that we have three versions of ARM processor: ARM 7, ARM 9, and ARM 10. Whereas in ARM 7, so this is the same processor which we are using in our lab in LPC2148 microcontroller. ARM 7 is based on the three-stage pipelining. So what are those three stages? And the first stage is called as the fetch, second stage decode, and third stage is called as the execute. All the instruction which will be executed on the LPC2148, it usually execute through the three-stage pipeline architecture. Okay, so again, ISB in system programming or IAP in application programming using on-chip bootloader software. So here in system programming, so directly we can interact with the microcontroller without any IDEs. So, and we can execute the programs on the microcontroller. So that's what in system programming means. In application programming means first we usually write the program by using some IDE, integrated development environment, like Keel, Microvision 4. So, and later after compiling that program, we usually dump that program onto the microcontroller to execute the task. So that's what in application programming means. And this LPC2148, it takes 400 milliseconds time for erasing the data in full chip, and 1 millisecond time for 256 bytes of programming. So it takes the microcontroller, the LPC2148 microcontroller, it takes 400 milliseconds time to erase all the data which is stored on the microcontroller, and it usually takes 1 millisecond time to process 256 bytes of memory, 266 bytes of data. Okay, it usually takes 1 millisecond time for 256 bytes for programming or to process. Okay, so coming to the microcontroller kit, so this is the microcontroller kit which we have in our lab. So here you can see this is the ARM processor. Okay, so this is the ARM processor, as I told earlier. So it is a quad flat package. So quad flat package, and again, so it usually looks like flat in structure, and you can see that there are four sides here. Okay, so there are four sides in this ARM version 7 processor. So this is the processor actually. So this is the processor. So ARM version 7 processor in the LPC2148 board. So here you can see various other device drivers that are connected or that are embedded onto the single board itself. So this is a single board. So these are the various segments. These are the various other segments or other drivers which are connected to this microcontroller. So this is the microcontroller board. So let's see what are the other components which we have in this microcontroller. So this is the pin where you need to connect. So this is the pin where you need to connect this pin to the CPU. Okay, so you need to connect this pin to the CPU, and this is the power cable. So you need to supply the power to the microcontroller. We usually connect this cable to the 5-volt DC power supply. Okay, this cable should be connected to the 5-volt DC power supply. So here you can see 7-segment display. Okay, so this is a 7-segment display. So there are 4 7-segment display in this board. Okay, so there are 4 7-segment display, and this is on off button. So at any point of time we can switch it on. So if we are not using this 7-segment display, we can switch off this 7-segment display. So there are 4 7-segment displays. So these are the device drivers which are embedded onto this microcontroller LPC2148. And again, here you can see that DC motor interface. So if we are executing, so if we want to execute the DC motor, so usually we connect the DC motor here. So there are 2 pins here. You can see here there are 2 pins. So here we usually connect the DC motor. So based on the programming which is loaded onto the processor, the DC motor will be the DC motor will be rotated. Okay, so again you can see here relay segment here. So again here we have a relay. So again we have a buzzer here. So we have a buzzer here. Then to connect the stepper motor, so we can connect the stepper motor to these 4 pins or 5 pins. So here we can connect the stepper motor. So this is the interface where we need to connect the stepper motor, and we have an IC for this. So usually this IC drives the stepper motor processed by the ARM version 7. So then we have a DAC here, okay, digital to analog converters. So if we want to convert any data from digital to analog, so then we will make use of this DAC. Then we have a switch circuit here. So we have 8 buttons. So we have a switches, 8 switches, on and off switches. So which and we have an LED circuit. So in this LED circuit, there are again 8 LEDs. So we can make use of we can make use this for our programming. So again, this is the keyboard. So this is the 4x4 keyboard. Okay. So here the keyboard is usually represented in matrix like structure. So there are 4 buttons in the columns, and also we have 4 buttons in the rows. So 4 into 4, so there are 16 buttons. So there are 16 buttons in this keyboard. So in some of the programming, we can, if we want to type or if we want to send any data to the microcontroller, then we can make use of this keyboard. And here you can see there are 2 external interrupts. So if you want to interrupt the process, if you want to interrupt the ongoing process in the microcontroller, then we can make use of this external interrupt. So basically there are 2 external interrupt. One is external interrupt 0 and this is external interrupt 1. So in our lab we are making use of this external interrupt 1. Okay, and this is the reset button, and this is the interface. So in this interface, usually this interface should be connected to the CPU, and this interface, power supply interface, should be connected to the 5-volt DC power supply. So this is how the microcontroller board looks. So in detail we will be studying. So when I explaining the program, so in detail I will be explaining about the interface which we are making, which we are make use of this interface in our program. Okay, fine. So this is how the microcontroller looks. So this is the microcontroller. This is the processor, ARM 7 version 7 processor. So it is a quad flat package, which means that there are 4 sides on there are 4 sides in the processor, and there are 64 pins in this processor. Okay, there are 64 pins in ARM processor. So 16 pins on each side. So we have 4 sides, 16 pins. So 16 pins on each side. So if you multiply 16 into 4, so it will be 64 pins. So I will let you know what are these 64 pins. So in the next coming slide. So this is how the microcontroller board looks. So this is the ARM version 7 LPC2148 evaluation board. So we have n number of interfaces. We can make use of these interfaces to execute the program. And this is the main microcontroller, or this is the main microprocessor, or this is the processor, ARM version 7 processor, which is there in this microcontroller kit. Okay, so this is how the microcontroller looks. So then coming to the this processor. So this is the ARM version 7 processor, which is situated in LPC2148. So we have an ARM processor. As you people know, ARM works on the reduced instruction set architecture. So this is an LPC2148 ARM version 7 processor. So as I told, so it looks like a flat in structure, and it has 4 sides. You can observe here. So there are 4 sides. Okay, so there are 4 sides in this processor. So, and as I told, so there are 64 pins in this processor. Okay, there are total 64 pins are there in this processor. So here 64 pins, there will be 16 pins on each side. Okay, on all these 4 sides. So there are 60. You can see here. So in this side, you can see pin number 1 to 16. And below here you can see pin number 17 to 32. 16 pins are there. Again in the right hand side, so we have pin number 33 to 48. So again we have how much? Again we have 16 pins on this. So again at the top we have 16 pins, ranges from 49 to 64. So total we have 64 pins, and in each and every pin, so multiple functions are associated. So there can be a single function or can be more than a single function. So we have multiple functions that are associated to each and every pins on this microcontroller. Okay, on this processor we have a 64 pins. So on each and every pins, multiple functions can be connected. So here each and every functions are separated by a slash. Here you can see. So for example, I will take up the second pin. So in this second pin, so there are four functions. One is port 022, one is AD 1.7, another one is CAP 0.0, and the fourth function is MET 0.0. So these are the four functions which are associated in this second pin. Ant ಹೇಳಿದ್ರೆ, so ಅಂದ್ರೆ a single pin can consist of more than one function. A single pin can consist of more than one function. ಅಂದ್ರೆ one function ಕೂಡ ಇರಬಹುದು ಇಲ್ಲ more than one function ಕೂಡ ಇರಬಹುದು. So based on our programming, we usually select this function by using a pin select. By using pin select, we usually select the corresponding function in our programming. So we shall later we can study that how the pin select works. Okay, so as of now you should know, that there are four sites in this ARM processor, ARM version 7 processor. So here there are 64 pins that are available in the ARM version 7 processor, LPC2148 microcontroller. So 16 pins on each side, 16 pin on each side. Okay, so this is how the processor looks. Okay, so this is the LPC2148 microcontroller. In this microcontroller, we have ARM version 7 processor. So this is how the ARM version processor exactly looks like. Okay, next we shall study about the pins which are associated in the microcontroller. So the pins are called as GPIO pins. So what is GPIO? GPIO stands for general purpose input output pins. Okay, GPIO stands for general purpose input output pins. So input output pins are the only way to interface with the microcontroller. If you want to interface with the microcontroller, or if you want to execute the program on the microcontroller, so IO pins are the only way to interface with the microcontroller. Okay, LPC2148 has two ports. Okay, there are two ports in LPC2148 microcontroller. What are those two ports? The first port is called as PORT0, P0, and port 1. So PORT1, P1. So it can also be called as port 0 or P0 and port 1 or P1. So there are two ports. One is port 0, another one is port 1. Port 0 is represented as P0. Port 1 is represented as P1. So there are two ports in the microcontroller. There are two ports in the LPC2148 microcontroller. And these two input output ports are of 32-bit wide and are provided by the 64 pins of the microcontroller. So all the 64 pins which are there in the microcontroller are associated with these two ports. Okay, are associated with these two ports. And as I told, these two ports are 32-bit wide, which means that the first 32 pins in the 64 pins are associated with the port 0, P0, and the next 32 bits and the next 32 pins and the next 32 pins that are available on the microcontroller. So all those are associated with port 1. Okay, so each of these ports, the size of each of these ports are 32-bit wide, which means that we have total 64 pins in our microcontroller. In that 64 pins, the first 32 pins are associated with port 0 and the next 32 pins are associated with port 1. So the naming convention of the input output pins on the LPC2148 microcontroller is PA.BC. So here P stands for port. Okay, A is the number of the port. So number of the ports, as I told, there are only two ports in our microcontroller, port 0 and port 1. So A can be either 0 or 1. Okay, so as LPC2148 has only two ports, A can be 0 or 1, and BC is the number of the pin in the port A. So BC represents the number of pins in the port A. For example, I will take one example. So here you can see P0.1. So P0.1 and P stands for the port, the number, then the next 0 stands for the port number. So here we are making use of port 0 and dot 1. So 1 is the first pin of port 0. 1 is the first pin of port 0, indicates pin number 1 of port 0. And another example is a P1.10, which indicates pin number 10 of port 1. So here you can see, so P stands for port and 1 stands for the number of ports. So port 1, we are making use of port 1 dot, then the pinth number. Pin number is a 10. So we are making use of the 10th pin. So that's how you need to represent the pin number and as well as the port number in the programming. Okay, now so PA.BC, where P stands for the port, A stands for the port number. Either it can be a 0 or 1. If it is port 1, it should be 0. If it is port 0, it should be 0. A should be 0. If it is port 1, then A should be 1. Dot BC. BC represents the number of pin in that port. In that corresponding port, it usually represents the number of pins. So this is how we need to represent the ports in the microcontroller. So again, I will be telling, so there are 64 pins, 16 pins on each side of the processor. So again, the first 32 pins are associated with port 0, and the next 32 pins are associated with port 1. Okay, there are two ports, one is port 0, another one is port 1 in the microcontroller. So again, port 0 is a 32-bit wide input or output port. Either it can be an input port or it can be an output port with dedicated direction control bits. Okay, for each physical pin. Port is a 32-bit wide input or output port with dedicated direction control bits for each physical pin. Out of the 32 pins, 28 pins can be used as general purpose bidirectional input output pins. So in port 0, as I told, there are 32 pins. In that 32 pin, you can make use of only 28 pins. Okay, you can make use of only 28 pins as a general purpose input output. You cannot make use of other 4 pins which are available. Okay, now so for all the programming in the port 0, you can make use only 28 pins. You can make use only 28 pins. The other 4 pins we cannot make use. So because those are not called as the general purpose input output pins. Okay, the first 28 pins are called as general purpose input output pins. You can make use of these port pin. We can make use of these port pins in port 0. So what are those? From pin 0 to pin 27. So you can make use of these 28 pins in port 0. Pin P031 is an output only pin. So pin P024 and pin P026 and pin P0 port 027 of port 0 are not available. You cannot make use of these 4 pins in the port 0. Okay, now you can make use of only 28 pins. So the other 4 pins, you cannot make use of this other 4 pins in your programming. Again, port 1 is also 32-bit wide input or output port, general purpose input or output port in port 1. So in port 1, pins from pin 1.0 to pin 1.15. And here 1 stands for the port number 1. 0.00 is the pin number. Okay, here to pin 1.15 and pin 1.15 and so again P stands for the port, 1 stands for the port number. Here 1 stands for the port 1.15. So 15 stands for the 15th pin. So in port 1, pins starting from P1.0 to P1.15 are not available. Okay, now you cannot make use of these P1.0 to P1.15, and there are 16 pins. You cannot make use of these 16 pins in your programming. So that are not available. And pins from P1.16 to P1.31 are the available general purpose input output pin. You can make use of these port pins. In the port 1, you can make use only 16 pin in the programming. So for the programming, you can make use only these 16 pins. So the pins from 16 to 31 in port 1. Okay, now port 0 we can make use of 28 pins except port 31, except 24th pin, 31 pin, 26 pin and 27 pin. In port 1, we can make use of only 16 pins. We cannot make use of first 16 pins, that is from P1.0 to P1.15, and later the next 16 pin we can make use of the next 16 pins in our for our programming. Then most of the pins in both input output ports of LPC2148 have more than one function. That is, they are multiplexed with different function. So as I explained in the so this is a processor, right? So here most of the pins are associated with more than one function. You can see here, for example, I will take up the 47th pin. So in this 47th pin we have four functions. So P01, P0 and the port 0 dot 17th pin, so CAP 1.2, CSK1, MAT 1.2. So these are the four functions which are associated in a single pin. And each and every pin will be associated with more than one function. And in certain number of pins there are only one function. In another set of pins, so there are more than one functions. Either it can be a two function, or it can consist of three function, or it can consist of four functions. So that's what it says. So most of the pins in both the input output ports of the LPC2148 have more than one function. So that is, they are multiplexed with different functions. For example, so pin 19 of the LPC2148 has three functions, namely port 0.0th pin, a general purpose input out pin, and TXD not. TXD not stands for transmitter output for UART0, and PWM1. PWM stands for pulse width modulator output 1. So you can see here in this diagram, so the 19th pin, so here you can see the 19th pin here. So in this 19th pin there are three ports. One is port 0.0, it is a general purpose input output pin. Port 0.0 and port 0th pin, it is a general purpose input output pin. Then with the second function is the TXD not. TXD not stands for transmitter, so transmitting the UART0 function. So then we have pulse width modulation, PWM1, pulse width modulation. So these are the three functions that are associated in pin number 19. So likewise, so we have 64 pins. So each and every pin consists of one or more function which are associated. Okay, so that's what about general purpose input output pins which we have. So I will brush up. So there are 64 pins. In that 64 pins, we can make use in that 64 pins there are two ports. One is port 0, another one is port 1. So port 0 consists of 32 pins, port 1 consists of another 32 pins. So in the port 1, in the port 0 we can make use of 28 pins. In the port 1 we can make use only 16 pins in our programming, for our programming. Okay. So next, coming to the pin select register. So if we want to select only a single function or in the microcontroller which is associated, so as I told, each and every pin consists of or associated with more than one function. So then we have a pin select register. So let's see what is this pin select. So how the pins are selected using this pin select register. Okay, at any point of operation, each pin can have a single function, and the function can be selected with the help of three configuration. And at a time, if a single pin consists of more than one function, then at a time you can make use of only one function. You can make use of only one function, and that should be selected by using this pin select register. Let's see how to select a single function from the pin. So the configuration register is called as the pin select PIN-SEL. Okay, now in short form, so you should represent the pin select function as a PIN-SEL. All should be in uppercase, PIN-SEL, and is classified into three registers. Okay, pin select registers are classified into three registers. What are those three registers? Until that, pin select 0, pin select 1, and pin select 2. So there are three registers: pin select 0, pin select 1, and pin select 2. So this configuration register is 32-bit wide. Okay, the size of the instruction which it can handle is a 32-bit wide. Any pin of LPC2148 can have maximum of three functions. Okay, maximum of three functions. One is general purpose input output. Other than general purpose input output function, so we have maximum of three functions that can be associated to the LPC2148 64 pins. So then a 32-bit pin select register can control 16 pins with 2 bits to control each pin. Okay, na? A 32-bit pin select. So as I told, each and every pin select registers can the size of each and every pin select registers are 32-bit wide. In this 32-bit wide, this in each register can control only 16 pins. Okay, na? 16 pins with 2 bits to control each pin. And each and every pin, 2 bits or 2 bits are associated to control the 16 pins. Like this is the important point. So pin select 0, the first pin select register that will control only port 0 pins from P0 to P0 ಅಂದ್ರೆ port 0.0 0th pin to P0 port 0.15th pin. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? So pin select 0 controls port 0 pins, port 0 pins ಯಾವ್ದು ಅಂತಂದ್ರೆ from port 0 0th pin to port 0 15th pin. Likewise the second pin select resistor, that is pin select 1, so that will controls port 0. Again it will controls pin select 1, so again that will control port 0 pins from port 016 to port 031. So port 016 to port 031, so these pins are controlled by the pin select 1. And the next, the third one, the third pin select resistor, so that is pin select 2, so that will control the port 1 pins. Whereas this pin select 0 and pin select 1, so both these pin select are controls port 0 pins, but whereas pin select 2, the third pin select resistor, that usually controls the port 1 pins. Okay, it usually controls the port 1 pins from P1.16 to P1.31. As I told earlier, we cannot make use P1.0th pin to P1.15th pin. So those 16 pins cannot be used as a general purpose input output pins in port 1. We can make use of these pin 1.16 to pin 1 port 1, sorry, port 1.16th pin to port 1.31st pin. We can make use of these 16 pins. And if you want to control the function which are associated to these function, then you should make use of this pin select 2. Pin select 2 controls port 1 pins from starting from port 1 to port 1 16th pin to port 1 31st pin. So this is all about the pin select resistor. So then we have some general purpose input output control resistor and instructions for programming. So there are 4 instructions for programming, so we'll be using these instructions in our programming. So just we shall have a brief idea, we shall have a brief idea on all these 4 instructions that we are making use of these instructions in our programming. I will be in detail explaining this instruction in the programming itself. Okay, first before going into the general purpose input output control resistor, so first there are 4 instructions. So the 4 instructions that are associated to the general purpose input output control resistor. So the first one is IOPIN, and the IOPIN stands for input output pin. Usually basically this is used to, this instruction is used to read the status of the pin. Okay, this instruction is used to read the status of the pin. IOPIN. So this instruction is used to read the status of the pin. So the second one, IODIR. IODIR stands for input output direction. Basically this instruction is used to set the direction of the pin. So either we can set the direction as input or we can set the direction as output. So basically there are 2 types of direction. One is input direction and the one is output direction. If you want to set to read the status of the pin. So what's the status of the pin? If you want to know the status of the pin, then we should make use of this instruction, IO pin. And the third one is IO set. So to set the pin to high state, so to set the pin to high state, then we should make use of this IO set instruction. So once we set the pin to high state, then it will start accepting. So it will start accepting the data. It will start accepting the data from the microcontroller. So it will start accepting the data and the data will be handled through this pin. Okay, IO set instruction is basically used to set the pin to high state, whereas the last one, IOCLR, it is usually to set the pin to low state. And whatever the data which is there in the pins, so that will be cleared and that pin will be set to low state. So that's what input output clear instruction means. So there are 4 pins. There are 4 instruction sets. So instructions for programming, one is IO pin. Usually basically that is, this instruction is used to read the status of the pin. IODIR, input output direction, basically this is used to set the direction of the pins, or either you can set the direction as input or you can set the direction as output. So then the third instruction we have in general purpose input output control register is IO set. So basically to set the pin to high state, this instruction is used to set the pin to high state. And IO clear, so this will set the pin to low state and it will clear all the bits, all the data which is stored on the pin. Let's study in detail about all these pins. The first one is IOPIN register. IOPIN, it is a general purpose input output port pins value register and can be used to read or write values directly to the pin. Okay, basically you can use this register to read, or you can use this instruction to read or write values directly onto the pin. The status of the pins that are configured as GPIO can always be read from this register. So as I told, basically this is usually used to read the status of the pins that are configured as general purpose input output, can always be read from this register irrespective of the direction set on the pin, irrespective of the direction, whether it is in input or whether it is in output direction. So basically this IO pin is used to read the status of the pin. The syntax for this register is IOX pin. So here you can see X is represented in red color. So just to highlight the thing, just I have represented this in red color. IO, this is O. IO stands for input output X pin, or you can also represent this instruction as IO pin X. So X na ನೀವು between IO and pin ಮಧ್ಯನಾದ್ರೂ represent ಮಾಡಬಹುದು. ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ at last IO pin ಆದ್ಮೇಲೆ, so you can represent the X. So let's see what is this X means. Where X is the port number. Port number andre, if you are making use of the port 0 in the microcontroller, then it should be represented as 0. Otherwise, if you are executing this instruction in port 1, then X should be 1. So here you can see, so this is the 0 IO 0 pin, or also you can represent it as IO pin 0. So there are two ways to represent this instruction. One is IO 0 pin. Another type is IO pin 0 for port 0, and IO 1 pin or IO pin 1 for port 1. So that is what IO pin register means. The second one is IO direction register, IO DIR register. So IO DIR, it is a general purpose input output port direction control register and is used to set the direction. So that is either input or output for individual pin. So by using this register, by using this instruction, you can set the direction for the pins. Either you can set the direction as input or you can set the direction as output. So when a bit in this register is set to 0, the corresponding pin in the microcontroller is configured as input. Okay na? So when a bit in this register is set to 0, the corresponding pin in the microcontroller is configured as input. Similarly, when a bit is set to 1, the corresponding pin is configured as output pin. Okay na? So 0 represent madidre, it usually represents the input, and 1 represent madidre, it usually represents the output. The syntax for this register is again IOXDIR. X stands for the port number here, or you can also represent it as IODIR X. ಹೇಗೆ ಬೇಕಾದರೂ represent ಮಾಡಬಹುದು in the programming. Okay, IOXDIR, and the other one is IODIR X, where X is the port number. So that is IO0DIR, andre IO port 0 direction, or IODIR 0 for port 0 pins. Okay na? If you are executing this instruction for port 0, then X should be 0. But otherwise, if you are executing the instruction in port 1, then X should be 1 like this. So IO1 DIR, or also you can represent or also you can represent this instruction as IODIR 1 for port 1 pins. So next one, methods to set IODIR register. So as I told, IODIR instruction is basically used to set the direction for the pins. So there are three methods to set the direction for the pins. Okay na? So there are three methods to set the direction of the pins. So the method 1, IODIR is equal to 1 left shift 3. Andre, so here you can see that we can setting the third pin. We can setting the third pin. Yav port andre 0th port. We are setting the third pin in the 0th port as the input, as the output pin. 1 stands for output. So we can, which means that we are setting the third pin. So there are 32 pins, as you people know. So there are 32 pins. So in that we are setting the third pin. So we are setting the third pin as the output pin in port 0. 0 stands for port 0. Method 2 is IODIR 0 or equals ಅಂತ ಹೇಳಿದ್ರೆ, again it usually represented as output. Okay na? Output is equal to 0x followed by 7 zeros 8. So ಇದು ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, again 8 represents the third pin. So how this will be represented in the third pin, I will explain you. So how this will be represented as the third pin. So first I will write the 32 pins. Okay, so here this is the 0th pin. Okay, this is the 0th pin, and this is the first pin, and this is the third pin. You can see, so this is the third pin. I represented as one. So 1000. What's the what? How you will represent 1000? So 1000 is represented as 8, right? So that is how you need to represent the pin number in this second method. So this is the second method. Okay, so this is the second method. By using this or equals, we are setting the third pin to high, or we are setting the third pin to the third pin as output pin, or equal stands for output. Artha ಆಗ್ತಿದ್ಯಾ? Here in the first method, 1 stands for output, 0 stands for input. Okay, na? So 1 ಅಂತ ಹೇಳಿದ್ರೆ, again I am setting the third pin as an output pin in port 0. Here I am setting the third pin as the output pin. Here output is represented as or equals, so in the port 0, in the port 0. Third method is IODIR 0 or equals. Again, or equals stands for output 1, left shift 3, which means that I am setting the third pin in port 0 as the output pin. Okay, na? So there are 3 methods. So you can use any of these methods. You can use any of these methods in your programming to represent the output, input and output direction. In your programming, you can make use of 3 methods. So there are 3 methods to represent IODIR instruction. Okay, the third one is IO set resistor. So IO set, it is a general purpose input output port, in general purpose input output port output set resistor, and can be used to set the value of a GPIO pin that is configured as output to high. So when a bit in the IO set register is set to 1, then the corresponding pin is set to logic 1. Setting a bit 0 in the register has no effect on the pin. Okay, na? So in this pin, in this instruction, you can set the pin to 1. So pin to 1 antele, again that pin will be that pin will be set, that pin will be set as the logic 1. Logic 1 andre high, which is nothing but output pin. High is nothing but the output pin. Okay, na? So you can make use of, if you represent 1 in IO set instruction, it usually corresponding the pin to, which is usually represent the corresponding pin to set the logic 1. And if you represent 0, so that has no effect in this instruction set. Okay, if you represent 0 in IO set, that has no effect, because IO set usually corresponds to setting the pins to high state. Okay, na? Low state you cannot set the pins to low state in IO set register. The syntax for the register is IOX set or IO set X, where X is the port number, so that is IO 0 set or IO set 0. So it should be set. Okay, IO set 0 for port 0, and IO 1 set or IO set 1 for port 1. So that is what IO set register means. So here the pins will be set to high state. Okay, so if you want to set the pin to high state, so that is nothing but IO, that should be done by the IO set instruction register. So which means that it will, the pin will be represented as the output pin. Then IOCLR register. So the fourth one is IOCLR. So it is a general purpose input output port, output clear register. So it usually to clear the output pins. So the usually this instruction is used to clear the output pins and can be used to set the value of GPIO pins that is configured as output to low, logic 0. So if you want to set the pin to logic 1, then you should make use of the IO set. If you want to set the pin to logic 0, then you should make use of this IO clear instruction. When a bit in the IOCLR register is set to 1, the corresponding pin in the respective port is set to logic 0. When the bit in the IO clear is set to 1, that pin will be selected and that will be set to logic 0. And at the same time, it will clear the corresponding bit in the IO set register. Whatever the data which is stored on that bit, that data will be cleared. At the same time, that data will be cleared. So setting 0 in the IO clear has no effect on this pin. So always it should be set to 1. Whenever you want to clear the data on the pins, in the pins, you should select 1. So the syntax for this register is IOX CLR, and input output X is clear, or input output clear X, where X is the port number. So that is IO0CLR or IOCLR0 for port 0, and IO1 CLR or IO clear 1, IOCLR1 for port 1. IOCLR andre input output clear. So these are the four general purpose input output instructions. So these are the four general purpose input output instruction register, which we will make use of these instructions in our programming. So this is all about the introduction which I wanted to give. So in the next video I will be discussing, I will be start discussing the first program. So the first program is DC motor. In the next video I will be explaining how the DC motor will be interfaced on onto the LPC2148 microcontroller.